I want to introduce everybody the zero-dimension magnetic content dot stereochromatic, we call MQCA. In this picture, we can see the hysteresis curve of a long-gap narrow magnet. We can see its magnetization displayed along the longest axis of the magnetic particle. And in this picture is the illustration of a magnetic computing array. When we put the input information, and the input information can propagate from the input devices and toward the output sensors and through the narrow magnet array interaction. And here is the clocking field. Then we see the calculated total magnetostatic energy. It's the two-coupled single-domain permeable narrow magnet. And in this picture, we can see where the short edges are adjacent, it will become the ferromagnetically coupled. And if their long edges are adjacent, it will become anti-ferromagnetically coupled. So the magnetostatic energy is a function of the magnetization direction of the right dot. And is dominated by the shape and isotropy of the elongated narrow magnet. And the magnetization energy of the dots are bistable, so they have a 2-bit energy minima, and their direction is parallel to the magnet's EC axis. One is the 0 degree, and the other one is 180 degree. Next, we see how the clocking field affects the magnetization of the narrow magnet. We can see they have some functions. First, the clocking field can overcome the energy barriers that between the metastable states and ground state. Second, it can control the rates that electrons quantum mechanically turn on between the dots in the QCA cell. And thus, it will switch its polarization. So it's the function that the clocking field can do. Then we have the question that how data flow directionally in the narrow magnet. First, in this picture, we see when the clocking field is 0, they are in their initial configuration in their metastable state. And when we increase the external field, you can see the magnetization will be horizontally into a neutral large state we call the neutral state. And then when the magnet is closest to the driver, is biased, then in turn biases the next magnet because of their dipolar coupling. And in the end, the field is removed, they will become their final ground state and have the anti-ferromagnetically order. So it's the clocking field that can make data flow directionally in the narrow magnet. Then we see the majority logic gate of MQCA. Here, we put the input information in A, B, C narrow dots. And then the external clock field can make all the systems have into their ground state. And the narrow dot of the end, the central dot, can operate this information and give the result into the out narrow dot to have the output information. And this is the symbol of the majority logic gate. So, for example, if we put ABC 100, the majority number is the 0. So we can get the output as 0 number. And this picture is the design of majority logic gate of MQCA, and they are fabricated without the input. Here is the AFM image, and B and C are the NFM image. You can see in the C picture, there are 5 different black discs that circle the different narrow magnets. And for our eyes, it easily can identify the different narrow magnets. And you can see the picture, they have the 2 coupling chain. In the parallel direction, you can see the AFN coupled with the 25 nanometer dot separation. And C this direction have the ferromagnetically coupled chain with the 35 nanometer dot separation. And why we have the 2 different designs? Because the design can balance the 2 coupling. Second, it will set the same clock field. And for further testing, we put the 3 additional input dots here that they can determine the states of A, B, and C. And next we see the similarity dynamics of the majority operation. First, we we have the inputs 011 and 100. And then the picture is a time evolution of the magnetic state of the gate. You can see the field ramps down from 500 millitesla to 0 millitesla. When the field is 500 millitesla, all the mechanization are in their normal state. And below 200 millitesla, you can see B, C, they try to align with the central dots in the same direction. And the central dots and the dots A, they switch to their final state. And in picture D, you can see the output dot switches next. And when the field is attained to the 0 millitesla, can see they relax into their magnetic state. And all I mentioned above is the zero dimension, the magnetic logic gate. And thank you very much.